Hello and welcome to the Gravel Ride podcast, where we go deep on the sport of gravel cycling through in-depth interviews with product designers, event organizers, and athletes who are pioneering the sport. I'm your host, Craig Dalton, a lifelong cyclist who discovered gravel cycling back in 2016 and made all the mistakes you don't need to make. I approach each episode as a beginner to unlock all the knowledge you need to become a great gravel cyclist. This week on the show, we welcome Matt Conte, one of the founders of Outbound Lighting. You may remember Outbound from a number of years ago when they originally launched the company via a Kickstarter project. I, for one, pay a lot of attention to Kickstarter cycling projects for some reason. I'm a sucker for them. And I was sort of curious, with so many industry stalwarts in the lighting business, how this company was going to make a mark. Well, they successfully funded the campaign and have successfully built a company manufacturing in the United States, which is absolutely amazing. But what was equally amazing was Matt's description of the technology that he applied to the bicycle lighting industry. He came from automotive lighting and had a lot of advanced engineering skills specific to how to light the world in front of you at night. And it was fascinating to just hear his take on the existing bicycle light industry and further how he evolved the very specific lighting options that Outbound uses and offers customers today. I've been using their helmet-mounted light as well as their bar-mounted light and definitely appreciate a number of things about the design that Matt will get into for you during this episode. So I hope you enjoy it. And just a quick note, I apologize for a little bit of sporadic release of episodes these days. I've been traveling and had a ton on my plate, and it's been a real struggle to get to the editing and everything else involved in the podcast. So I appreciate your patience. There certainly will be another couple weeks towards the end of the year where I take off just to decompress, but look forward to getting many, many more great episodes out the door to you in the coming year. With that said, let's jump right into my conversation with Matt.
Matt, welcome to the show.
Hey, pleasure to be here.
I'm excited to dig in and learn a little bit more about Outbound Lighting. Why don't we start by just letting the listeners know where you are in the world, and then let's talk about what led to you starting Outbound Lighting in the first place.
Yeah, so we are located in just north of Chicago, Illinois, in Skokie, just kind of a middle suburb and stuff. And then we got Tom, my co-owner, he's out in Olympia, Washington, kind of the Mecca of mountain biking out there for him. Couldn't convince him to move to the city, unfortunately. But yeah, so we got our headquarters here is where we design, assemble, ship every bike light that we make. And I guess from as far as what got us to start this company, like you sort of mentioned, that kind of interestingly, I'm not that kind of guy hardcore biker who saw an opportunity to make something. I came from the automotive lighting world, used to design LED headlights, off-road lights, stuff like that for like Baja trucks and things like that. And I was really into rally car racing, where you're on gravel roads, slinging cars 100 miles an hour at night through the woods to blast. But at the time, I was kind of looking to how to basically branch out and take my experience from developing lighting products to something else. I just kind of wanted to do my own thing. And so I looked at experimental aircraft, I looked at exterior architectural lighting, all that kind of stuff. And wasn't until a friend of mine posted on Facebook, I see a selfie of him riding at night. He's being like, oh yeah, we're out here night riding. I was like, that's, you got a couple headlights on your bike? Like, what is that? Like, what are you using? And, I got the Night Rider 1800 Pro. It's the best light out there, all that kind of stuff. And I looked it up and it was like $350. And I was like, it's a flashlight. And talked to him for a bit, kind of like, hey, can I come over and check this thing out? Kind of seems like this is possibly an opportunity to take what I've done in the automotive space and bring it to bikes. And so, yeah, he took me out on a ride and I enjoyed it and had a lot of fun and kind of was like, yeah, I could definitely do way better than this. And from there, I designed a prototype, gave it to him. He liked it, loved it, ran a Kickstarter campaign, was able to raise enough money to pay for the initial tooling of the product, and bada bing, bada boom. 5 years later, here we are. And we've now got 3 different products. We've gone through a couple iterations of stuff. And yeah, now the goal is basically just continue to build the best bike lights that we can using all of the experience that I used to have from the automotive sector.
Interesting. So that goes back to, was it 2017 for that original Kickstarter project?
Yeah, just about. I think I was starting to kick the idea around like 2016 or so, and then drew out some sketches, made some models, 3D printed a bunch of stuff. And I was doing this all like after hours from my normal job, kind of trying to keep those two things completely separate. And yeah, so it was about 6 months, 8 months of just prototyping, validating, doing a bunch of stuff until it was like, all right, we've got something that looks production enough. Let's make a Kickstarter campaign and let's see what happens. I kind of use that as sort of that litmus test of either all my friends and family are wrong and it's not really a great product, or we do have something that other people who are outside of our little sphere of influence actually find useful and want to have and all that kind of stuff. So that was kind of my testing ground, just to see if this is what people wanted. And turns out enough people wanted it that we were able to get that started and into production and all that kind of stuff.
It's such an interesting kind of validating ground for new products, Kickstarter. It's got both incredible advantages, but also risks in terms of like getting your fundraising across the finish line, et cetera.
Yeah, it's certainly not as good as it used to be. Like I feel like Kickstarter usefulness, we're on the tail end of it. Not as many. A lot of people have been burned in the past by products that just never came to market, all that kind of stuff. And it was kind of a challenge to like advertise and get the word out that this is what we're doing. And it's even harder nowadays. I think Kickstarter sort of pivoted their entire model away from like products to artists and creators and games and all that kind of stuff. So yeah, it's certainly not as good as it used to be, but it's definitely one of the best spots to kind of figure out, is this what people want?
Yeah.
And it's sort of a low cost, low risk kind of method before you go and dump $50,000-$60,000 worth of tooling just to find out that you don't have a market, which I'm sure some people have done that, unfortunately, but that's the way it goes.
I do remember when the product came to market on Kickstarter, simply because I sort of follow Kickstarter and certainly bike projects on Kickstarter with a lot of interest. And it had me thinking about the sort of decades of bike lights that I have experienced or have in the garage, dating back to when you used to have the battery in your water bottle cage attached by a wire to your headlight. And if you could get 250 lumens out of that setup, it was sort of miraculous.
Yeah.
And then I remember the sort of escalation of lumens being the sort of main driver of innovation. Like the form factors weren't changing too much. I just kept seeing this escalation of lighting power, so much so that, when you got up to even north of 500, 600 lumens, you were getting outshined from behind. If the person behind you had a brighter light than you, it created this weird shadow, and it was worse than having your own light on the bike because they were so powerful behind you. And I think we'll get into this a little bit, but they were very sort of flashlight-like and very directional in their beams. So it's interesting, and I want to get into it for sure, your form factor and how that evolved. But let's start with, you mentioned that you had a cycling friend who kind of showed you his lights that were state of the art at that moment in time. What did you see in that light that, given your experience in the automotive industry, you felt was, a dramatic shortcoming and the thing you could improve upon very easily?
Yeah, definitely. So the first thing that I kind of noticed, just because a lot of the bike lights were kind of similar to sort of like the cheap off-road lights that I'd see in the automotive side, where it's basically just an LED sitting inside of a reflector bowl. It's kind of your most common, typical, standard flashlight type of optic. And the problem with that is that gives you one pattern. It's just going to be a straight up circle. You're going to have a tight hot spot from where all of the light was bouncing off the reflector sides and concentrating on the middle. And then you're going to have like a secondary ring of all the spill light coming straight from the LED. So you end up with a very concentrated hotspot, an outer sort of just dimmer ring, and then a hard, sharp edge around the outside. And that's sort of what creates that sort of tunnel vision effect, like when you're riding quickly with behind one of those kind of lights. And basically, we have not done that in the automotive sector since the 60s. We've all been shaped light with lots of, if you look at any headlight on a car anywhere, the ones that are super basic with just a reflector bowl, even like the old halogens, they're all multi-segment reflectors, and they're all doing very little things to redirect the light into certain areas. Because the automotive lighting sector is so heavily regulated, you have lighting targets that you have to hit. You have to get a certain amount of light at 0 degrees, 0 left and right, and 0 degrees up and down. Like it has to be 100, I'm thinking off the top of my head, like 200 lux or something like that. But then off to the left by 15 degrees up, 5 degrees down, you have to have a certain amount of candela requirement to legally sell a vehicle. So the DOT and all that kind of stuff have set up basically all these lighting standards for high beam, low beam, turn signals, brake lights, every kind of lighting you can think of. It's been standardized for minimum targets. But in the bike lighting world, especially off-road kind of stuff, and especially in the US, it's kind of very interesting how Europe and the US are completely segmented. We can get into that later. But in the US, there's absolutely no targets. There's no requirements. So the goal there was always just build a brighter looking light, not always necessarily make it more useful. And I kind of feel like that segment was always so small and niche that nobody was taking the advanced software packages that we use in the automotive side to bikes, because I have personally designed reflectors and stuff for clients and things like that, and it gets expensive really quick. The software package that we use costs $25,000 to $30,000 a year just to license, because it's such a niche automotive specific lighting package. There's only maybe 50 companies in the world that are using it, but it is what lets us redirect and shape light the way it is. And so when I rode with those older Night Rider lights, and I don't want to call them out specifically because pretty much every brand is almost the same, that kind of what I noticed is these were all just flashlights. They're the same beam patterns that you would expect from a flashlight that you're going to use around your house, walking around the woods and all that kind of stuff. And I saw that opportunity to basically be like, all right, let me sit here as a driver, not so much a rider, but like how would I approach this problem if I was doing this from an automotive perspective? I could, okay, I'm going to be, my eye lines here, my lights mounted 2.5 feet below me, 6 inches in front. Okay, I know that I want to be able to see with a reaction time of 10 seconds while riding at 35 miles an hour, the fastest, like super fast downhill. I know that in order to recognize an object, you need 3 to 5 lux of light. Okay, if I know I'm doing 35 miles an hour and I want 10 seconds, I can figure out that distance that I need to have something illuminated with 3 to 5 lux, and then backtrack that to figure out how much candela that I need. And that sets my minimum target in the center. And then basically I can then shape the beam pattern so that we hit that minimum target so it feels bright enough, and then we take all the other lumens that we have and kind of spread that around so that we build essentially a wall of light, which is exactly how we do it in the automotive sector. A lot of fine tuning and figuring out what targets we want to hit at what beam angles. All right, let's go into our software programs. Let's spend a couple weeks iterating, optimizing, simulating all these different types of beam patterns, tweaking the reflector facets individually until we get what we feel is an appropriate beam pattern for that specific type of light. Then we can prototype it, test it, make changes. It's a very iterative process there. But yeah, it's pretty much that first night ride that I had was very eye-opening as far as, yeah, like if this is the best, we can do so much better. And there's so much more opportunity to develop good lighting utilizing the automotive sector and bring it to bikes rather than being just another biking enthusiast who's putting together a really bright LED into an off-the-shelf reflector and calling it a bike light kind of thing. So that's kind of how I see like our paths to arriving here being a little bit different than other companies, especially in the lighting space. But it does seem like a lot of biking companies start from biking enthusiasts, which obviously that makes sense. And so that's kind of how we arrived to that point and got there.
Yeah, it's super interesting taking it with a kind of first principles, fresh eyes look, and taking what you learned in the automotive industry. You know, one of the sort of hallmarks of the outbound lighting visual is it's sort of wider. You know, you think of a lot of these lights and they're, you know, essentially akin to a flashlight or circular or just square light right in the center, kicking out a lot of lumens as you just described. The outbound lighting profile is quite a bit wider. What do you do with that extra space? You mentioned how you sort of can really fine tune where you want the extra lumens to go to, et cetera. What are you doing across that big visual front plate of lights?
Yeah, so That's also kind of playing into the whole like physiological way that our eyes respond to light. Our eyes prefer very evenly lit spaces. Because you can kind of imagine like when you're driving in a tunnel and you come out of the tunnel and you get that like big flash of brightness, how it takes a little bit for your eyes to like auto expose, I guess, like from a camera perspective. The same thing happens when you're riding at night. If you're riding behind a light that's like very bright in the center and has harsh edges, when that light is moving around, like your eyes are constantly trying to balance this bright object moving around in front of you versus when you have a very wide, even beam pattern, it feels a lot more like daylight. And that's kind of like why we feel so comfortable riding around in the day because everything is evenly lit from not only from like where you're trying to look, but also all the ground in front of you from like where you're looking all the way out to the front of your tire. And so that is definitely like one of the biggest challenges as far as like developing an optic is to set up the beam. And again, the surfaces on these things have to be so precise. The tooling for them is very expensive, but it's part of like why it's so good. Basically, what we're doing after we set that target hotspot that we want to hit, then like you said, we're taking all that extra lumens and stuff, and then first of all, I'm trying to like make the lighting from the where you're looking all the way to the front of your tire as even as possible on the ground. So I'm able to basically set up like a sensor plane in my software for brightness and then set up like a driver perspective, or in this case, a rider perspective. But since we're using automotive software, we're always using driver. So I set that up and then basically I'm able to like do cross sectional curves and make sure that we don't have any like weird ripples or really intense peaks, which you can kind of see if you study a lot of different beam patterns all over the spectrum from like the cheapest lights to the most expensive lights, you'll see like there's splotchy areas where light just gets a little bit more concentrated. You might not notice it, but it isn't until someone like me points it out kind of thing. But it's a really, really tough job to try and do that. And that's sort of like where I find the value in the software that we use to be so valuable. Because yeah, once we set like the ground plane to be evenly lit from the front of your tire all the way out you're looking, then that's where I like try to expand the width. And then more importantly, try to taper the brightness so that it's you get all this peripheral spill light to the side that never shows up in pictures, never shows up in video because it's just so faint that camera sensors can't really pick it up unless you start playing Photoshop and brightening stuff and all that kind of stuff. But our eyes are incredibly sensitive optical instruments. So our eyes start to pick this stuff up. And then from the very outside corners, I very progressively try to ramp up that brightness to the center so it feels very smooth and progressive. And that's sort of one of those things like that's why like when you shine one of our lights like against the garage wall or the back wall, it's not going to seem as bright compared to some other lights because we spread it out so much. But it is one of those things like once you're on a trail, on a road, pitch dark, and you turn on our stuff and you give your eyes a few minutes to adjust, and it's one of those things that people just never want to go back to another type of light. And it really is all those little details and days of simulating and tweaking and simulating and tweaking and simulating and tweaking over and over and over that it really pays off. And I'm pretty sure that, I mean, I know that's kind of like why our lights have been so well received. Is that, yeah, it's something that no one else has really done before because it is a very expensive iterative process that if you try to hire that out to somebody else, like you have to give them the targets. You have to say, I want it to be this bright. I've got this much light I can do. Make it work. And I'll give you $10,000 or $15,000. And that guy's gonna do 2 days, 3 days worth of work, and be like, oh, here you go. Versus like us, we're obsessive about it. I've been up till 2 or 3 in the morning just simulating, tweaking. Because every time I simulate, I'm like, all right, I'm gonna let this simulate. I'm gonna go to bed. And be like, wait 5 minutes, like, oh, but I'm so close. Let me tweak this again. And all right, another 5 minutes. If I just move this another degree to the left, it'll be all right. And then, boom, 3 o'clock in the morning, and my wife's wondering why I'm not in bed yet. And it's that kind of obsession with lighting is like, it's why I enjoy what we do. I love what we're doing, making lights and all that kind of stuff. And I think that really shows in the products and
Yeah,
customers.
there's a lot of detail we can get into on the lights. So after the Kickstarter project goes off, you've amassed a little bit of capital to presumably pay for some tooling and get some of the basic products off the ground. What was your vision for how you would assemble the product? Where are the components coming from? And did that change from the original Kickstarter first version to what you guys are doing now?
Yeah, so at first, like the previous company I was at before, we did a lot of stuff overseas just because like the tooling is cheap, all that kind of stuff. And so initially, like after we ran the Kickstarter, we raised like 30 grand. I still needed like another 40, so I ended up getting a home equity line of credit against our house at the time. So I was literally betting the house on this working. Thankfully, it did. But it was one of those things where I wanted to work with domestic tooling companies and all that kind of stuff. But the problem is that you need a lot of scale. So these guys usually don't even want to like start talking to you until you're doing like 5,000 units, 10,000 units. And at the time, I needed 500. I just needed enough to get going. So in order to get the company off the ground, we had to go overseas as far as like getting the tooling going, because they'll do the tooling cheap and they'll do it with low minimum quantities because all they really care about is the tooling. While domestic suppliers are more for the recurring orders that come in every day or every quarter or whatever. And so we were able to get stuff started and make the initial shipments and all that kind of stuff. And all the tooling was done overseas. The PCBs, the actual printed circuit boards, and the assembly was done still stateside. At the time, I was using a company out in Kansas City. We've always kept the electronics stateside because that's the part of developing these products that needs a lot of hands-on experience and needs a lot of like quick turn reaction. Parts will be out of stock and all right, quickly we got to find another resistor that can drop into this and all that kind of stuff. And that's where you need that good kind of communication lanes, which don't always get going overseas. But when it comes to like a rubber strap or just a die cast piece, like, yeah, you can go overseas and do that kind of stuff. But my goal was always to try and build the company up to the scale that we could do more domestic manufacturing. And we finally have kind of reached that point where we're building 10,000 Evos this year. Well, I think we did about 8 or 10,000 this year. And once you get to about 6 to 8 to 10,000 units per year, that's when domestic manufacturing makes a lot of sense. Not just but the tooling is going to be more expensive, the lead time's a little bit longer, but the per unit cost is going to be a little bit cheaper. And more importantly, you're going to save a ton on shipping, tariffs, all that kind of stuff. And so, as well as just being able to quickly react to different changes and things like that. So we now have a fantastic supplier out in Michigan. They do automotive components as their bread and butter, but they also like working with small manufacturers like ourselves. And so we're able to now utilize a lot more advanced materials. We're using thermally conductive plastics and everything, which I think is an industry first. We're able to it's one of those things like the quality just gets so much better as you're able to bring things domestically, but you can't do that until you get the scale. And so it's kind of like a chicken before the egg thing where either you can have a ton of money and you can do it right away and just make a big risk, which I couldn't do because we didn't have investors, we didn't have anything. It was just me betting the house against some tooling that I hope works in an industry that I don't have a ton of experience in. But now we've gotten to that point where every single new product that we develop is almost 100% stateside developed. We do all of the assembly and manufacturing in-house. I've invested a lot into automation, robotics, stuff like that, mostly because I love playing with them. I'm an engineer and I love programming them and trying to figure out how to make things better, faster, quicker, not just from lights, but also how we can build things better. So we're able to build 30,000 lights a year with just one production guy, overseeing 3 or 4 different robotic systems.
Wow.
That autonomously dispense grease, they autonomously solder. I've got an order right now for a cobot arm, so we're going to have like an arm that's picking up pieces, snapping them together, checking the torque on all the screws, checking the force to snap those pieces together. Basically, you can turn it on an optical sensor and make sure that the light output is exactly what it needs to be. If it's not great, kick it off to the side. Someone else will look at it. But for the most part, trying to do everything I can to basically make this business run as smoothly as possible so that we can just continue to focus on building better products and as well as like the customer service and all that kind of stuff. Because yeah, for me, it's one of those things that if you build a great product first, everything else becomes easy. If you build a product that just works every time, you don't need a huge customer service department that's handling warranties and all this kind of stuff. If you build a product that's just simple to operate. You don't need complex instruction manuals telling you how to turn on the light. Like it just turns on, it goes, and all that kind of stuff. So to me, it's kind of one of those things like we'll always spend the extra couple bucks on genuine components and all that kind of stuff, automotive grade sealants and plastics, so that this stuff just won't break. And if it does break, we just fix it. We just feel like, if it breaks, it's an engineering issue. We'll be able to figure out how to make it not break, and we'll be able to work with our suppliers quickly to modify the tool. And 3 months later, we'll have the product with that problem solved. And so our stuff is incredibly iterative. The product that you buy a year from now is probably going to be very slightly different than what you would get today, just because we're constantly trying to stamp out every little issue that comes up. And so, yeah,
Yeah.
it's
Yeah,
been
I
great.
love that. I love that benefit of US manufacturing and having that tight relationship so you can take the customer feedback if you're listening and just put it right back into the product. And sometimes it's minor, but it's always a step in the right direction, whether it's for performance, durability, what have you.
Yeah, yeah, exactly. And it's one of those things that it sounds easy on paper, but it's shocking like how many companies don't actually do that.
Yeah.
The
Yeah.
place that would have,
Listening to customers is surprisingly hard and actually doing something about it, I found.
yeah, yeah, it definitely is. But
Let's 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 talk about the outbound lighting lineup as of today. What are the different models? And I'd love to just talk a little bit about the intention of the various models.
yeah, yeah. So like that's sort of another one of those things that makes us unique in the space is that we make a different light for each specific purpose. We're not just making one light at three different power levels or five different power levels. We've got our like bread and butter, which is more for mountain biking, is the Trail Evo. That's like a handlebar mounted bike light. It's designed to go on the handlebars. It's pretty heavy, so it's not going to fit on your helmet, and it's just incredibly wide, even beam pattern, so that you can be moving your handlebars, 30 degrees to the left, and you'll still be able to see where you're going. And then we have our hangover light, which is an ultra lightweight, very slim, low profile helmet light that's designed to go on your helmet. It can work on the handlebars, but it's not great because it is a narrower spot, because wherever your head is pointed is probably where your eyes are looking. So we can kind of take that beam pattern and narrow it down and still have half the lumens, but still the same peak output as our like handlebar light, if not a little bit more.
That's so interesting. And sorry to interrupt, Matt, but I spent a bunch of time with the helmet mounted light, the Hangover recently. Loved it, by the way. And hearing you describe kind of the very purposeful difference. Honestly, my entire lighting life, I've stuck handlebar mounted lights on my helmet.
Yep.
And there was no distinction between the two. It was just like, okay, great. For the uninitiated night rider, like having a helmet light is important because as you turn your head, as you're going through sweeping corners, a lot of times, certainly with traditional lights, the light on your bar can disappear. All of a sudden, you're going through this arcing turn and you're actually not seeing the trail. You're seeing off in the woods.
Yep.
And, you touched on this in a couple different ways. One, on your handlebar lights, you've described how you've tried to purposely widen that lighting profile so that you can turn that 30 degrees and still be in the light. But the addition of the helmet mounted light just gives you that additional ability to kind of look even further. So by my likes, when I'm mountain biking, the ultimate combination is definitely that Evo plus Hangover helmet mounted light.
Yeah, definitely. And that's where those two lights we also designed to work in concert with each other. So like the exact same color temperature, pretty similar beam punch strength. So you're not like one light isn't overpowering the other, but it is once you're like looking off down into a hairpin or something like that. That's where it's like you get the brightness of the helmet light, but we make sure that the peripheral spill blends well enough that you're not ending up looking at like two distinct lights. Like it still feels like an unbroken wall. And so that was like a really important part of the design constraints that we set up when we set the initial lighting targets for both of these lights was they need to work well together. So I think it was like 135 degrees off center is like what I aimed for. So basically your handlebars are dead ahead and you're looking like way back behind you. And I still wanted to make sure that those light was blending a little bit so it didn't feel like you saw a black hole basically in between where you're looking and where your handlebars are pointing, so it always feels unbroken. Because as long as you do that, then your eyes are not going to like I keep saying like auto exposed, but it's not really the terminology. But basically your eyes aren't trying to adjust for the blackness
Yeah.
here and the bright intensity. So as long as it keeps it unbroken,
Yeah.
also it's like as you ride it longer, your pupils start to open up because they're so used to it. They're not having to contract and expand and contract and expand with the varying brightness levels. As long as it's consistent, your pupils can slowly expand and take in more light. So even though we're working with lower lumens because we want to have a longer battery life, by just having that unbroken wall of light, it ends up feeling brighter as you get used to it because of the fact that your eyes are physically opening up more and able to take in more light. Just like when you sit in a room for 5 minutes in the dark, your eyes start to open up and you can start to see a little bit better. The same thing effect happens with just dim lighting and all that kind of stuff. And so that's sort of where that philosophy of make sure everything's evenly lit ultimately ends up helping a lot more as far as like having the light feel a lot brighter, even though the numbers on paper don't seem that impressive. But of course, that's one of those things that you can't break that down into a one line item on an ad. You can't show that in a picture. You can't show that in video. It's one of those like you just got to get out there. You got to ride with it. You got to try it. And so that's why like word of mouth for us is our biggest
Yeah.
seller, pretty much.
Well, hopefully this deep dive into podcast will be a good mechanism for people understanding like the depth of engineering that go into these products and the thoughtfulness that you guys have put in there. I think before I interrupted you, you were going to talk about the third light in your lineup.
Yeah. So that's our newest light, which is called Detour. It's basically like a road beam headlight that's designed for gravel riding and road riding. The main difference is that it's basically like a low beam on a car headlight. It's got a cutoff line where it's basically a horizontal line where the light doesn't go above it. So that way you can aim the light up and flat and still be able to see really far down the road where you want to go because you can put the brightest part of the beam right there, but you're not blinding oncoming traffic, which is a big deal, especially for gravel riders, road riders, where you're approaching other riders coming towards you, pedestrians and stuff like that. Definitely don't really need it for mountain biking, as a moose doesn't really care if you don't blind him or not. He's still going to be in the middle of the trail. So yeah, that's our newest one, which again, it's a very specific type of light. It's designed to be a handlebar light, designed to be front and center on your bike, and designed to be aimed in a certain way so that you're not blinding oncoming traffic and stuff. And that's still very wide beam pattern, very progressive lighting from where you're looking all the way out to the front of your tire. I've got side marker lights and stuff so you have better side visibility for traffic or things like that. But yeah, it's just another one of those, like, we're not going to come out with a Detour 1500 or a Detour 2000. Like, this is the light. It does around 1200 lumens. You're able to get a lot brighter hotspot because of the fact that you're not putting half that light in the sky because you got the cutoff beam pattern, so it feels brighter than it actually is. You can get good run times and all that kind of stuff. So yeah, because
it still boggles my mind as someone who started out with a 200 lumen light back then as being like the pinnacle of performance, that now you can get 1200 lumens in this incredibly small package. No battery, no external battery. It's all right in there. It's just astounding.
And you still get an hour and a half, 2 hours of runtime, and weighs, was it 135 grams or something? Yeah, and I mean, we've got some other designs in play right now that gets that even smaller. It's sort of like, looking towards the future, because, like you said, it started out with like halogens and car batteries. That was kind of how it started out 20 years ago, 30 years ago, and then HIDs bulbs came in. They came out with little really miniature HIDs that, again, they did 250, 300 lumens, but they were power sucks because you waste most of that energy in just heat, like the heat coming out of the lamp. But then in around 2005, 2006 is kind of when LEDs became a lot more mainstream. You were able to get them cheap enough that you could build cheap products with. So you saw that explosion, not only the automotive side, because that was like when I was really into that, went from the HID off-road lights to rigid industries coming out with all their LED stuff. And the same thing in the bike side. That's like when Knight Rider came out, their first, I think it was the Newt or the Lumina, their first Lumina, like 2005, 2006. Again, 300 lumens, 400 lumens, maybe, all that kind of stuff. But then over the last 10 to 15 years, LEDs have gotten I'd say there's about a 5 or 10 year stretch where LEDs just every year, just huge leaps, huge leaps, huge leaps, and then kind of slowed down and stuff. Now the biggest technological leaps in LEDs have basically come from the miniaturization of them. So, and that ultimate that's been driven by the automotive sector. The automotive sector requires smaller and smaller optics, which means that you need a smaller and smaller source, aka the LED. The LED has to be as tiny as possible so that we can control the rays that are coming, the rays of light coming out of the LED. So we can control that on a very small optic, and you can put that exactly where you need to. Because if you put a huge LED inside of a tiny optic, you're just going to get scatter everywhere. It's not going to be well optimized and all that kind of stuff. So the automotive sector has driven the LEDs to become smaller and smaller and smaller, and they come out like the lumen values don't look impressive on paper. You'll be like, oh, it's only 300 lumens on this, but that's kind of like why our Trail Evo has 9 of these LEDs, because you can put these tiny, tiny LEDs into a tiny optic and still get incredible beam control. Versus if you try to take like a Cree XHP 3.0 or whatever the biggest LED is that can do 1300, 2000 lumens, but it's massive. It's like a centimeter wide. You need a ginormous optical reflector to put that into for it to be of any use. Otherwise, you're just scattering light everywhere, uncontrolled. And you see that a lot on a lot of cheap lights. We can tell that they looked at the data sheet, they saw, ooh, 1300 lumens, that looks great. And they're like, well, but we got to fit it in this little thing. So let's just take this LED, slap it into that. Cool, we got a really bright light. And it's like, yeah, but it doesn't do anything well. It's either extremely concentrated or it's just blown out. Um, and so, man, I kind of go off on tangents a lot if you can't tell. So yeah, like the technological jumps, LEDs have kind of slowed down a bunch, and now they're just incredibly tiny, incredibly power dense, and it's great for us. But there's not much more that LEDs can do. Like we've kind of reached the final form, I guess you could say. But the next big technological leap that's going to be really interesting to jump into is batteries. All these automotive companies, again, automotive is leading the sector that kind of then drips down into bikes. All of the solid state batteries that every single automotive company is investing into, companies like Solid Power, all that kind of stuff, they're basically promising these batteries that can charge instantly. They can put out huge amounts of power. They won't be as affected by thermals as much, so you can run them really cold or really hot, and they won't lose a lot of life, and just a lot more power dense. And so to me, that's going to be like the next big generational leap. Not going to happen next year. It's not going to happen 2 years from now, but maybe like 5 or 6 years. We hope that we can get 21700 cell batteries in a solid state battery for a reasonable price, and that's when these bike lights can either be twice as bright for the same runtime or last twice as long for the same brightness. And that's going to be also incredibly lightweight. Those graphene batteries, I think, are like half the weight of a single 21700 cell.
Wow.
So that'd be
refreshing.
Yeah, and that's going to be really exciting once those can start coming online. But again, that's probably 5 years until that becomes more mainstream, if they have these technological breakthroughs that they keep promising. Thankfully, it's not as vaporware as like hydrogen energy, but we're getting close, I feel like. And so
a couple nuanced things I wanted to point out before we let you go is, correct me if I'm wrong, but you can actually charge the light while you're running it.
Yeah,
which it may seem counterintuitive to people that doesn't exist across the board, but I'd say the vast majority of lights I've ever run, you could not have an external battery pack to kind of top it off if you needed to.
Yeah, pretty much most bike lights, either you have your external battery pack that you have to plug into, and once you unplug it, it dies because obviously you don't have any power. Or you plug it in, you can't turn it on because it's just simply charging. Or if you can plug it in and turn it on, it's just going to be stuck in a low mode because the charging current going into the light isn't enough to like actually power the light. So what we've done, knowing that we had a lot of customers who do 24-hour races and all that kind of stuff, we do USB-C pass-through charging, where you can basically plug in the light, and sort of the way that we can do it is that the light is being powered off the battery, but we're charging the battery with an external power bank. So you can technically, if you're running like Evo on high with a sort of a low current battery pack, you can technically outrun the battery pack and end up running down. But if you're running like a medium or low, basically the battery pack is charging the battery faster than the LEDs are pulling the power out. So we're not trying to do like a straight through, like the light isn't being powered by the external battery pack. The external battery pack is charging the battery inside the light, which is then being used. So yeah, that was basically just kind of like as one of those like customer requests, like, hey, how can we use a cheap Amazon power bank to power my light? Can I do that? And like, oh yeah, we can. I don't see why not. Like, you just set up the charging protocols and all that kind of stuff so you can allow that to happen. It gets really complex. Turns out USB stuff is not as easy as it seems. All these like handshakes that have to happen between two different components, and it's a real pain in the ass. But Tom, my co-owner out in Seattle, he loves that stuff. So while I'm up at 3 a.m. tweaking beam patterns, he's up at 3 a.m. trying to tweak USB charging
I
protocols,
love it.
kind of stuff. So yeah,
I
there's
love it. And
unique features. Yeah.
the final detail I wanted to talk about was just the mounting mechanisms that you guys have designed, because I found them to be very clever and slick and unobtrusive, which is not something I could say about a lot of the mounting mechanisms I've had to endure from other lights.
Yeah, I mean, you should have seen some of the prototypes that we came up with before we landed on this one. They were large, ugly, or finicky and not great. But the current one that we use for hangover, we just simply use what everyone has used for the last 15 years, which is just a standard action camera. I can't officially say GoPro anymore because now they clamp down on that, but it's a GoPro mount. So everyone's used to that. It works great. Low profile. A lot of bikes have those built into it. So why not just make sure our helmet light works with that out of the box, which is why Hangover has the action camera tabs on the back of it. But for Evo and Detour, that mounting system was one of those like real hard design challenges because like we obviously buy like every single competitive light we can get our hands on, and all of them, they always have at least like one or two good design features. I'm like, that's a good idea. I'm gonna just take this and put this in mine. But when it came to mounting, I literally could not find anything that I was like, this is great. Because a lot of the mounting things were, if they were secure, they were really hard to put on. Like you could not take them off with like a pair of thick winter riding gloves, which for me, that's always been like a design standard. Make sure that we can operate anything on a light with a thick pair of winter riding gloves, because most of our customers are riding at night in the winter, and it sucks to not be able to turn on your light or mount it or anything like that. So we went through a lot of iterations trying to figure out how in the world we're going to mount this light so that it can quickly be taken on and off and all that kind of stuff, until one of my friends, not related at all to bikes or anything, he's a big camera nerd, he's like, hey, you should look at Manfrotto's camera mounts, or the tripod stuff. Super simple. People have used it for literally 40 years. I bought one of them. I'm like, this is a really good idea.
That's so interesting that you say that. Now that you say that, I'm like, oh yeah, that makes sense. I've seen that before, and that's where I've seen it.
Yeah. So basically, I took the Manfrotto design. I checked for the patents. They all expired in like the late 90s. They patented like in the 70s or 80s. And so it's basically a free-for-all. You can use it. You're not going to infringe on anything. And basically, I took what they did, miniaturized it, and tried to make sure that it works so that no matter what, you could have it mounted vertically and the light isn't just going to fall to the ground. So we put in little notches and stuff like that to capture it. But for the most part, it's a Manfrotto camera mount designed for bikes, or for bike lights. And so all of our lights, all of our handlebar lights, have that basically standard nub size on the back, aka a Manfrotto camera base plate that can slot right into our quick release mount, and click it in, push it back, closes the plunger, torsion spring snaps it shut, and you just push down in the lever to really secure it in place. Little serrated teeth with a big thumb screw that can, again, easily be operated when you're wearing a pair of gloves. So you can adjust the beam angle without having to over tighten the mount or anything like that. Yeah, it's one of those. That mount is on its third iteration. We've already got a fourth one in work right now because we want to get rid of the hex screw and all that kind of stuff. So we're going to try to do like an overcam mechanism and everything. Yeah, I don't know if you ever got to experience the first ones where I did them out of die-cast aluminum and powder coating, and that was one of those hindsight 2020. I really wish I hadn't done that, but now we have glass fiber mounts. They work great. The smooth action, all that kind of stuff. It's, again, it goes back to that whole situation of like, let's just iterate, let's quickly make changes, don't worry that this cool tool costs $5,000. Like, we've got to make the product good. If it's not easy to operate for customers, then no one's going to like it.
Yeah.
And all that kind of stuff. So
awesome. Well, thanks for walking us through the lineup and that backstory. I love hearing your journey. It's sort of admirable to get out there on Kickstarter and put yourself out there on the line. As a former small business owner myself, I feel that pain of when you mortgage your house just to get the product off the ground. And congrats for ultimately bringing it back to the US for manufacturing. As you mentioned, so many advantages there, let alone helping the economy, but just advantages that you can continue to roll out better and better performance and take that customer feedback to heart every time it comes through.
Yeah, definitely. Yeah, it's always the goal. It makes business sense from a money profit standpoint, and it makes sense just from the product standpoint. We're able to, and the goal is to just continually advance ourselves further. So like these thermally conductive materials are something I wanted to use for almost a decade, but we just never had the volume to justify it, because I have to purchase 3,000 to 4,000 pounds of this material, just like the minimum order quantity, which is equivalent to like 10,000 units. And when you're starting out, you only have 500 or 1,000 for the entire year. It's like, yeah, I can't justify that. But that's sort of our business goal, is like just continually advance and kind of pull away from the competition by integrating these technologies that is not as easy to integrate from the start, or you need the scale. So yeah, that's where we got a lot of fun things planned. We've got a long list of things we want to do. We're trying to push into more bike shops next year. Like we've got our manufacturing dialed, we got the robots in place. Like we can finally like outpace building from our retail website demand. So now we're kind of trying to expand into bike shops. We're getting like retail displays developed and all that kind of stuff. And so that's sort of where we're hoping, if any bike shops are listening, you can always go to outboundlighting.com and talk to us.
Connected.
Get you all hooked up and everything. That's where, and if anybody has ideas and stuff like that, we're always open to listening. If you email us, it's going to be either come to me, it's going to come to Tom. Like there's literally 4 people in the company. That's it. And so it's very personable. You're going to talk to a real person. We don't have any bots running, thankfully.
Right on, Matt. Thanks again for the time. I'll make sure everybody knows how to get in touch with you, and super informative, and congrats again.
Yeah, I appreciate it. It's been great chatting.
That's going to do it for this week's edition of the Gravel Ride podcast. Big thanks to Matt for coming on the show. I hope you, like I did, learned a lot about lighting and the nuances around the lighting choices we can make as cyclists. If you're interested in supporting the show, you can visit buymeacoffee.com/thegravelride, where ratings and reviews are hugely important. If you're interested in connecting with me, I encourage you to join the Ridership. That's www.theridership.com. That's a free global cycling community, tons of people and interesting conversations going on in any given day, so I encourage you to join that. Until next time, here's to finding some dirt under your wheels.